Okay, so I'm going to do my best to walk you through this example. It's an example I provided it for the exam. And one thing to note is that the audio might not sound that great, so you'll just have to turn up your volume if that's the case. I'm recording on my iPad, and I haven't figured out how to get good quality audio out of the iPad using the program I use. Um, if anybody knows, let me know. Reach out. I'm using an app called Explain Everything. Um, for your future classes, it's a good app to take notes in. It lets you import notes, slides. It's great for the Apple Pencil if you're using an iPad. Um, so, anyways, here you have a question, right? And one thing to note is, well, first of all, let me just be clear that we will have questions like this on the exam, but don't get scared away from, but don't get scared by these questions because it's actually a lot more information than you need. It's just meant to give you context, right? So let's go ahead and read through this question, and I'll point out what you actually need to answer this question. Let me get a highlighter out. So, one thing to note, and this is the first thing I would suggest you do on my exam, any exam, is go to the last part and see, well, what is the actual question? You'll see this kind of framing in GRE questions and questions on any standardized test. You'll see this kind of framing oftentimes. Um, and here you see that it's asking specifically for the main effect. Or actually, it's asking how many main effects. So the first thing you need to know is, well, what is a main effect? If you don't know by this point, you will have to go back and do some review. But let me just give you the shorthand version of that. Let me change. So a main effect is just looking at one IV. So let's look at this one. Focus of the activity, right? Now you might get confused about, well, what do they mean by focus of the activity? What does that mean? You don't need to know that. You just need to know that focus of the activity is one IV, okay? And when we're asking, is there a main effect for focus of the activity? What you're asking is there a difference between dogs and cats or dogs only? Now, again, you're probably asking, what does that mean? What's dogs and cats? What's dogs only? These are the two levels of, let me change to a pen, this IV, right? This is the IV, is level, I'm just going to call it level 1 and level 2. I'm just giving it a number so you could realize that it's a different level of the same IV, right? So that's essentially what we have here. So similar to some of your studies, you might have had sex, male is one level, female is another level, sex is the name of the IV. Same idea, right? When you're asking for the main effect, you're just asking, is there a difference between how people performed when they got dogs and cats or dogs only? Or in that example I give you about sex of the participant, we're asking, is there a difference between male and female participants, right? Those are the two levels. So when we're asking for the main effect, we're just focusing on one IV at a time. Yes, we have two IVs. Here's the other IV, right? But we're only focusing on one at a time. So if I ask you, how many main effects are there in this design? Just by knowing how many IVs you have, you should know it can't be more than that number. So we have two IVs. So the number of main effects cannot be more than 2 because we have two IVs. Okay? So remember, when we're asking for main effects, that's what we're asking. So you would go here first, realize, oh, he's asking about main effects. I know because we have two IVs here, it's at most 2 main effects. Now I can go into this information and see if there's anything else I need, okay? Now, just one more aside. If I was asking about the interaction, then I'm asking about both IVs. If I'm asking for main effect, I'm only asking about each individual IV, and within each IV, are there differences between the levels? Okay, so let me change back to the highlighter, go to the question, and I'll give you these questions so you should be able to find these. If you can't find them, let me know. I could point you to them. They should be in the same area. So this says, Dr. Elder was interested in the way people recognize objects as member of categories. For example, what makes us recognize a dog as being a dog and not a cat? More specifically, he was curious as to whether people think about categories in a more complex way if they contemplate the opposite category first. So this is just giving you some background, right, about the study, what the researcher was thinking about, because as instructors, we want to give you context for the numbers, right? Now, this is background information. You don't actually need this information to answer that question I have below. So let me keep reading. For example, does a person think differently about the category of Southern if they first think about the category of Northern, right? So you might be reading this, and it's actually kind of considering, well, when we think about something in opposition to another thing, does that change the way we think about it? But in your reading of this question alone, you might get confused, but take a moment, take a step back and look back at this question and see, like, well, do I need all this to answer this question, right? That's something you should be asking yourself as you're reading it, as you're reading this question. That's why I suggested going and finding the actual question first before you read what's above. Okay, so he's also curious as whether people categorize things differently if they're exposed to a category member compared with generating a category members. See, even I got confused there. He is also curious as to whether people categorize differently if they are exposed to category members compared with generate. Okay, so if they're exposed to the categories versus creating the categories themselves. Again, so far, you don't need that. That's just background. Okay, this is helpful. There are 4 groups of participants. Okay, that's helpful. We actually can determine that just by looking at this too. We have 4 cells. We have 4 categories of participants with 30 people in each group. That's good to know, but the numbers in each cell we actually don't need. But here is more explanation about what the study is about and what the levels are. Again, that's kind of giving you background, providing information that might help you understand what's going on in these numbers. But, and I know it might seem like, well, then why are you giving us this information? I'm giving you this information because ideally I want you to care about what these numbers mean, okay? But at the same time, I want you to succeed in this class. So I'm pointing out, okay, this is useful information to understand what's going on. But in this specific question, you can actually answer this question with minimal information from this description. Mostly, I would be focusing here. I would be focusing on the fact that there's 4 groups, but then also if you look at the table, you can figure that out. 1, 2, 3, 4, right? 4 groups. There's 30 people in each group. Good to know, but not essential. And here's a description of the actual study. Okay. Now, if I asked you to solve for main effects, now look at what specifically I'm asking. How many main effects? I'm not asking, is there a main effect for type of activity? I'm not asking if there's a main effect for focus of the activity. I'm asking, how many main effects are there? We know there could at most be 2 in this example because we have 2 IVs. Remember that. There's a potential of 1 main effect for each IV. So it could be 0, there could be no main effects. It could be 1, there could be a main effect for just 1 IV. Or there could be 2 main effects. Can't be more than the number of IVs. Okay, let me go ahead and move this over a bit. Okay, let me erase my markings on this wrong one. No, there you go. So we could solve. And I'm actually going to try to cut this out. Give me a second as I figure this out. There you go. Good enough. Move that over. Make this bigger. Okay. So what you want to do in this situation is you want to calculate the marginal means. Okay, so keep that in mind. When you're looking for main effects, you calculate the marginal means. Let me show you how you do this. So if I only asked you for type of activity, you would go this way. 10 plus 5 divided by the number of numbers, because we're trying to get an average, gives us 7.5. Here happens to be the same numbers. And keep in mind, you're averaging. It's not always divided by 2. But we have two numbers, so we're dividing by 2 in this case. We have 7.5. Now we compare these marginal means. And if they're the same, you would say there is no main effect for type of activity. So if I only asked you for type of activity, you would say there is no main effect for type of activity. But I'm not asking you that. I'm asking you how many main effects. So let's do the next one. Focus of the activity. Is there a main effect for focus of the activity? So in this case, we want to go this way. Let me change the color. Okay, let me move this over for a second. 10 plus 10, 20 divided by 2 gives us 10. 5 plus 5 gives us 10 divided by 2 gives us 5. Is there a difference here? Yes. So you would say there's a main effect for focus of the activity. So in this case, where the question was, well, how many main effects do you have? You would say, well, there's not one here. There's one here, so we know it's not 0, it's 1. There is one main effect. Now, this is what you would do when solving for main effects when you only have 2 IVs. So keep that in mind. This is for 2 IVs specifically. Let's see. Kind of lost my train of thought there. Yeah. One thing I want you to just remember is what we're essentially doing is we're getting an average. So that last calculation, we are getting an average for dogs and cats and dogs only. And we're seeing, well, based on these averages, does it look like there's a difference? And for type of activity, we're getting an average just for cutting out pictures and drawing pictures and seeing based on averages, right? 7.5, 7.5. Does it look like there's differences here? No, it doesn't look like there's a difference between cutting out pictures and drawing pictures in terms of these values here. So these values here are actually the averages. Let me actually go back here. So these numbers here are averages for all the people, all the participants. If you read here, there's 30 participants in each cell. So this is an average for all the participants. If you want to get a better idea of the DV, you can read this description and you'll realize what the DV is. But I just wanted to show you that if you kind of feel confused, stuck, you don't need that to be able to solve this. But conceptually, it's good for you to know what it means, right? These are cells, these are averages. These cells are averages for all 30 participants in that condition. Dogs and cats, cutting out pictures, and so on, right? Here's another average, here's another average, here's another average. Okay, so that's solving for a situation where I'm asking you for the main effects and you have 2 IVs. Keep that in mind. You have to figure out how many IVs and you have to know what is it that's being asked of me, and look here to see, well, what information do I actually need from here? Is it mostly being given as background information so I could understand the question? As you saw here, I could solve for main effects, I hate to say it, but without looking at the description of the study. But you're always going to have the description, right? Because they're giving you, and I'm giving you the context for what you're thinking about, what you're answering, and what the study is. And I want you to get used to understanding statistics within the context of a study. But yes, you can solve it just based on this. Okay, so here you have another study format, or another question format that's asking, well, okay, what's being asked? You'll notice in some of them, I try to highlight a question. I try to make it easier for you to find the question, right? Now let me change to a highlighter. Okay, so here the question is, how many two-way interactions does Dr. Rai have in her study? Okay, one thing to keep in mind. A two-way interaction is an interaction between two IVs. Yes, I didn't give you the names of the IVs, but you could probably come up with it, right? Read through the question, what's being talked about. This is most likely, well, actually, let's read through it together. Dr. Rai is a cognitive developmental psychologist, we don't need to know that, who studies how children learn mathematical principles. That's good to know. Her current interest in studying how children learn multiplication, that's her current interest. She recruits 54 second graders. The study conditions include, okay, this is where we're starting to care. Learning material. Aha. Learning material. Right? Learning material IV. Students read a chapter on multiplication from their book, or, here's the other level, students watch a video of cartoon characters explaining. Book, cartoon character, right? Good. That's good to know. This is a question where it's more helpful to read than not to read because you understand how the design. Then if that's learning material and we only have a 2 IV setup, then this has to be the teacher IV, right? Students are taught by multiplication from a teacher. Students are taught multiplication by a 4th grader. Kind of cool. I don't know if that would work. It might work. And let's see. In all conditions, participants spend 30 minutes learning the fundamentals of multiplication and are then given the same 15-question multiple choice test. So that's the DV, right? So we know that these numbers are averages. They're averages regarding what the score was for each group of students, right? The students who received a textbook and were taught by a teacher on average got a 6. Textbook taught by a 4th grader, 2. Cartoon video and taught by a teacher, 2. Cartoon video taught by a 4th grader on average is 6. Okay, so now we understand what the information means. Let's go back to the question. How many interactions? Okay, now I do have two-way interactions because that is covered in this chapter. But usually, when you get a question and it only has 2 IVs, you're asked, is there an interaction? And it's kind of implicitly understood that you're asking, is there a two-way interaction? So here I'm essentially asking, not essentially, here I am asking, is there a two-way interaction? I say how many, but here's the thing. If you only have 2 IVs, at most you can have 1 two-way interaction, because a two-way interaction is an interaction between 2 IVs. In a situation where you have 3 IVs, there could be multiple two-way interactions because you have more than 2. Here you have only 2, so the only possible interaction I can have is between the teacher IV and learning material IV. This is usually used to indicate interaction. Multiplication sign. In your output, it was represented as a star, which is a representation of multiplication when people write it out in computers. Okay, so we know there can only be 1 or 0. So if you see options that are, okay, are there 3? Are there 4? You know automatically, nope, I'm not picking those. I'm going for either the 0 or 1 option. I get it. It's kind of misleading, but if you understand what I'm asking, if you take the time, then it's a fair question. I'm actually making it easy for you because even if you don't have a hard time calculating this out, you could at least take this out, and 0 or 1, even if you had to guess, you have a pretty good chance. You have a 50% chance now because you've been able to eliminate those 2 other options because you know that it's only possible to have 1 or 0 two-way interactions, right? 1 or none when you're dealing with 2 IVs. Okay, let me go ahead and cut this out. How did I do that last time? Here you go. Remember, we're asking about two-way interactions. This time, we're not asking about main effects. So two-way interactions have to deal with 2 IVs at a time. Main effects, 1 IV. Okay. All right. So the way to do this is by subtracting to figure out if there's a two-way interaction between these 2 IVs based on a table like this. Okay. And you choose one direction. You could either subtract this way or this way. I'm going to go down, okay? So I'm going to go down and I'm going to say, okay, 6 minus 2, it's going to give me 4. 2 minus 6, it's going to give me negative 4. This negative matters, right? So you don't just throw away that negative. 2 minus 6, that's a negative 6. You want to keep that negative. Okay, so then you assess, are these different numbers? Now, I forgot to mention for the main effects, if there's any difference at all, even if it's a 0.25 difference, say that there's a difference and report a main effect. I don't want you to get stuck on deciding, well, is that a large difference? Your textbook talks about that, but I think it's unfair to put that on you because you would need to know more about the scale, right? Well, a 0.25 difference might not mean a lot when we're talking about a single point on an exam. But if we're talking about a 0.25% difference and we're talking about millions of people, that 0.25% might be thousands, right? So my point is, if there's any difference at all between the numbers when looking at main effects or even interactions, you say, yes, there's a main effect. Yes, there's an interaction. So this one's kind of tricky because you see that they're the same number, just one is negative. For interactions, if there's a difference in sign as well, you would say there's an interaction. The difference is how we get these numbers. We subtracted, right? We subtracted 6 minus 2 and 2 minus 6. 4, negative 4, yes, there's an interaction. And if you're kind of like confused and you're like, well, what? Like, what's that mean? So keep in mind that your textbook shows you that when you have an interaction in a line graph, right? Let me go ahead and draw something out. If it looks like they're going to intersect at any point, even if you have a spreading interaction, so this is a crossover interaction, this is a spreading interaction. Even if they're not crossing, but they're not parallel, this would be parallel. Then you would say there's an interaction here, there's an interaction here, not here. So how does this apply? Let me actually redraw these numbers as a line diagram. let me make space. So if the subtraction method kind of confuses you, I actually find that most of the times it doesn't, but some students get anxious and like, well, did I do that right? Well, you can check by converting that table into a line graph. So, okay, so let me draw this out. You have to choose where each IV goes. I'm going to put the learning material on the bottom, on the y-axis. So that's going to be textbook. Whoops. And this is going to be cartoon. I'm actually going to 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to label the y-axis. Okay, so that's textbook, that's cartoon. What you normally do with this, you choose a color to represent the other IV. So I'm going to use red for top eye teacher. Okay, so top eye teacher, textbook, 6. Top eye teacher, cartoon, 2. Then connect them. Oh man. There you go. Maybe I should get, here, hold on, I'm putting a pencil here so I can use it as a ruler. So if you're doing it on this paper, it'll be easier. Okay, good enough. Okay, and then I'm gonna use blue for taught by 4th grader. And taught by 4th grader textbook 2. I actually drew that red lower than I should have. Let me fix that. It would be around there. Back to blue. So, okay. So, textbook, taught by 4th grader textbook is 2. Taught by 4th grader cartoon 6. Hopefully you're seeing how they cross now. Okay, so that's the best I could do. But you can clearly see that even though one's I didn't want to do that. Let me change to pen. Let me undo that. Even though one's a positive, right? And one's a negative, it still indicates an interaction, and you could clearly see that when you draw it out like this. So if you kind of want to double check, you can always do this, but subtracting is enough. If you see a difference, like if this was a, let me just make them some hypothetical answers. Okay, it doesn't let me erase. But let's say this was a 3 and a 2.5. You would still say, yes, there's an interaction. 3 and 3.3. Yes, you would still. As long as they're different, you would say there's an interaction. If they're positive, negative, they're still different. You're not likely to run into this when you're looking at the main effects. This usually happens when you're looking at interactions. So one thing to note is that what this is actually telling you, this is more conceptual, right? So up to this point, I've shown you how to work this out. You would have enough information so far at this point to answer the question. Is there a two-way interaction, or how many two-way interactions are there? We know it's only 1 or 0. Is there 1? Yes, right? Because it's a 4, a negative 4, and we even drew it out to confirm that there's an interaction. But just so you can understand what you're doing when you subtract, you're looking at the difference between here and here. That positive 4 and negative 4 are telling you that there's a likely crossover interaction, right? So keep that in mind when you're subtracting. It's not always going to be a crossover interaction. Sometimes you might be getting something like this. What you're actually doing is you're getting the difference between here and here. And that's just more for you to conceptually understand what's going on here. All you need to know, though, is, okay, if they're asking me if there's an interaction, I choose a direction. I went down, and then I subtract. Now, keep in mind, if I went this way, 6 minus 2, 4. 2 minus 6, negative 4. See, same thing. So you can go either direction. Um, okay, keep in mind, I'm just giving you additional information so you know, right? If you got it up to this point, you're good to go. Go and study. But for those of you who are kind of just like, oh, okay, what does this mean? Or give me more. You can also do it this way. You can also subtract that way. You can also subtract this way. It doesn't matter. I'll just actually stop there because I don't want to confuse anyone. But keep in mind when you're looking for interactions, you're choosing a direction and then subtracting. Keep in mind you want to read the question to know what I'm asking. And if you've been reading, if you've been following along with the videos, you should understand what a main effect is. You should understand what a two-way interaction is, right? In this case, not in this case, a two-way interaction is an interaction between two IVs. So we know that because of that, if they're asking me how many two-way interactions there are and there's only two IVs in this example, there could only be one interaction. The other possibility is 0. Maybe there is no interaction. So the questions are going to require that you understand the language, that you understand the concepts to answer them. But if you break it down, it's not that difficult. Putting aside everything I explained, to look at the interaction, you're just subtracting. 6 minus 2, 4. 2 minus 6, negative 4. Yep, interaction. One interaction. For the other example, you're just averaging, right? You just have to know what's being asked. If I'm asking you how many interactions, then work out all the well, let me take a step back. If I'm asking how many main effects, work out all the main effects and then let me know. If I only have two IVs, you should know there can only be two main effects total. For interactions, and there's only two IVs, you know there can only be one interaction at most. This is knowledge that you all have accessible. It's also, you can look this up, keep that in mind. So yeah, do your best. I'll stop there. I know this is scary. It's not scary. It's not more than you can do. Take your time, process information, look for the question first, and then solve. And if you have questions about this example, reach out to me before the exam, right? During the exam, I can't answer your questions. But before the exam, I'm happy to walk through examples with you. So don't hesitate reaching out if you need help.